Hey students, this is lesson 128. In this lesson, you will be able to calculate slope and understand slope as the constant rate of change in a line. First of all, let's look at the definition of slope. Right here, the slope of a line is the ratio of the vertical rise to vertical run. Slope equals rise over run. All right, we're going to use that idea to help us determine slope. Let's go ahead and check out the next page. All right, slope in the real world. So check out a couple examples of slope. Since it's rise over run, we can use a hill to kind of demonstrate what slope stands for. Let's look here at this truck right here. What this is for is a steep grade on a hill to warn truck drivers to watch out for the grade. And 8%, you probably remember that 8% means out of 100, so that's the same as that ratio, 8 out of 100. And let's go ahead and look at that line. Let's graph what 8 over 100 would look like on a line. I'll use this graph right here. So what that means is when we go over 8, we could simplify that, divide both these by 4, and we get 2 out of 25. And if I were just to quick make a table of x and y values, now with x, since it's rise over run, y is actually on rise and x is on run. So let's say we start at 0, 0 with this truck right here. And for every 2 miles that the truck goes up, so that's your rise, it's going to go over 25 miles. And if we continue that another 2 miles, we'll add another 25. So we get these ratios and keep going. 6 would be 75. 8 would be 100. There's our 800ths. 10 would be 125. Let's use that one on here. So we'll say that. So our run is 100, that's on the x-axis, so if I go over 100, that'd be from here to here, I need to go up, rise up 10, that would be there. So if I were to draw a straight line on that, that line would represent that rise over run from that 8% grade. And let's take another look here. Now notice this line up here goes down. Rise over run can be a negative value also. If I use these 2 points to help me out here, that flat line there is the run and that is the rise. Now if I'm going to the right on the run, it's a positive run. If I'm going down on the rise, that's a negative. So now I'm going to count from, notice that line goes from 50 to 90. Well, that's 40. So my run is 40 there. And then I'm going down from 40 to 35, that's down 5. So I can write that. My rise over run is negative 540, which is the same as negative 1/8. And if I divide that, that's negative 0.125. And what that means for this problem is for every 1 chair produced, our cost in dollars over here goes down by about 12.5 cents. So that's what that means. All right, so what we need to do is learn how to find the slope. Okay, and this problem right here will help us do that. First of all, let's label these coordinates. What are the coordinates of points R and S? R is 1,6 and S is 412. So we have the coordinates R 1,6 and S 412. Okay, now we want to find the slope of the line. Well, I can just do rise over run. And if I do that, my rise goes from here to here, from 6 to 12, which is up 6. So that's a positive 6. So rise over run. My rise is 6, and then I'm going to go over here. That's from 1 to 4, which is over And since its direction is to the right, that's 3. And that gives me 2 when I divide those two numbers. So my slope here is 2. What that means is I go up 2 for every 1 I go over on that line. Up 2 for every 1 I go over. Okay. Notice that the scale is 2. That's why I'm saying I'm going up 2 for every 1 I go over. Okay. This next question said, is the order in which you subtract the coordinates important? Well, one thing I want you to notice here is if you look at these two numbers, the 6 and the 12, those are my y coordinates. The difference between those two numbers is actually my rise. So I can just take my 12 minus my 6 to get my rise, which is 6. And I can take my x coordinates, the 1 and the 4, subtract those, and that gives me the run. And I get the same thing. Well, did it matter which way I subtracted those? It really doesn't. What if I would have switched them around and used and did 6 minus 12 instead over 1 minus 4? Then I get negative 6 over negative 3, but a negative divided by a negative is a positive, so I still get a slope of 2, so it's exactly the same. Now, what we'd like to do is generalize on this, which means try and find something that you can always use from this. And what we can find is that that if I just say I have 2 different y coordinates and 2 different x coordinates, which is what I had for these 2 points here, what I did is I subtracted my 2 y coordinates, and then I subtracted my 2 x coordinates to get my rise and my run, and that became my slope. You're going to see that we use the letter M a lot to represent the slope. All right, so let's go ahead and try that. Let's see if we can find the slope here between these 2 points. I'm just going to quickly label them here. So there's my x1, x2, and you could label the second set, sorry about that, x1, y1, meaning my first point. And this is my x of 2, y of 2. And so I'm going to take, to find my slope, I'm going to take y2 minus y1, divide that by x2 minus x1. My y2 is 89. My y1 is 45. My x2 is 65. And my x1 is negative 23. Subtract negative 23. 89 minus 45 is 44. 65 minus negative 23 is 88. When I divide those, I get 0.5. So the slope between those 2 points is 0.5 or 1/2. All right. Let's move on. What's that? All right, one more problem we're going to do here. Let's say that we know a line has slope negative 2/3. Well, remember that negative 2/3 represents a rise and a run as a ratio. And I can think of the top number as negative 2. So my rise is really a drop because it's a negative. I'm dropping 2 for every 3 that I go across on my run. So, and that would be to the right because I'm considering that a positive 3. So if I were to graph 4, 5 up here, that's that point right there. And I know my slope is negative 2/3. That means from there I need to drop 2, which puts me here, and then I need to go to the right 3, and there'll be another point on that line. Drop 2, right 3, another point, drop 2, right 3, another point. So here's the line that they're talking about through those points. Can't make that a little straighter. Right there is my line through those points. All right. You could also do that on a table. Let's say we have an XY table. And we start at the point 4, 5. X is 4, y is 5. Y is the rise, so consider -2 as my rise. So if I subtract 2 from 5, I get 3. Subtract 2 from 3, I get 1, and so on. And 3 is my run. That means I'm going to add 3 to the x's. X axis is the horizontal axis or the run. So if I add 3 there, I get 7, 10, 13. Well, notice that's these points right here. This point here is 7, 3. This point right here is 10, 1. And this point right here is 13, -1. All right, that's it for this lesson. We'll talk about this more next time we meet in class.